Today we're going to be talking about compounding interest. So the first thing we're going to talk about is this question. It says you owe 12% interest each year on a $500 loan. If you make no payments and take no additional loans, what will the loan balance be after 5 years? And we're going to write an expression to represent the balance and evaluate it to find the answer in dollars. So with loans, you take out amount of money from a bank typically, and once you do that, they're going to allow you to take that money out, but then they're going to charge you a certain amount of interest as kind of payment for taking out that money from them. So this particular account or this particular loan has a 12% interest each year. Okay, so these are still exponential functions. Okay, so remember every exponential should be in the form y equals a times b to the x power, or f of x equals, or f of n equals, whatever it may be. And so remember that y, this is typically the ending amount. A is always the starting amount. And then b is the factor, the growth or decay factor in this. And then x is going to be typically time for any sort of word problem. So with this, again, A is the start, B is going to be our growth rate. Well, we have 100% of our stuff, whatever we're starting with, and then we're going to either add or subtract our percent to it, depending on if it's growth or decay. Okay? So we have to do 1 plus or minus the percent to figure out what that B value is. So for this, we would have y, or f of x equals. Our starting balance is $500. That's how much the loan is we're taking out. We don't have that amount of money, so we need that from the bank. And then they're going to charge us 12% interest. Now, interest, is that something that that we then owe, or they give us for free? So we're going to owe on that. They're not just going to give us an extra 12% amount of money. So for our B value, we need to take 1 and add to it 12% as a decimal. So we're going to take that 12 and we're going to move that decimal place over 2 times. So 1.12 is going to be our B value. And that makes sense in this situation. We're owing more money, so it is exponential growth. So we are going to multiply by 1.12 to the x power. Now, with this, I guess we could also do, this does say 5 years, so this x could actually be 5 years. And when we do these calculations, you type this in. So let's show this here. We get $881.1708416. Now, what of that do we actually need? We're talking about money, so how many decimal places should we use? So that would be 2. So we would have $881.17. So we borrowed $500. They're charging us 12%, and 5 years later, we've actually paid them $881.17. So that's why you got to be extremely careful how much you're taking out, how long the loan period is, and then obviously what the interest rate is. The higher the interest rate, the more money you're going to owe them. What was $500 is now $881.17. So you want to be extremely careful when you are taking out loans, because you're actually paying a lot more than what you would have had you just had that $500. All right, let's take a look at this. So, resizing images. Andre and Mai need to enlarge 2 images for a group project. The 2 images are the same size, so that's important. They're the same size. Andre makes a scaled copy of his image, increasing length by 10%. It was a little too small, so he increases the length again by 10%. Mai says, if I scale my image and increase the length by 20%, our images will be exactly the same size. Do you agree with Mai? So Andre did 2 different increasings, okay? And my is saying, all right, we could have just skipped this process and done 1 by doing 20 one time, okay? So we need to see what's happening here. Andre, let's just say there, since it's the same size, let's just say that we have the length of this is 10 inches, whatever you want to make it be. So for Andre, if he's got 10%, so we would be taking for this 1 plus 10% as a decimal, so that'll be 1.1. So if we're starting with that 10 inches, the first increase that he did, we would multiply it by 1.1 and get 11. And then he did that same 10% increase again. So we're taking that 11, multiplying it again by 1.1 since that was our increase, and we would get 12.1 inches. Okay, so that's the new length of Andre's picture after he's increased it twice by 6 or by 10%. So again, they're starting with the same amount, 10 inches, the same length. So then 20%, this would be 1 plus 0.2 because we moved that decimal place over twice. So my's factor is 1.2. And we are enlarging these, so this is a growth factor. If we multiply 10 by 1.2, we get 12 inches. So are these two amounts the same? So no, because 12.1 is not equal to 12. They're really, really close, but they are not exactly the same. So you cannot just take these two percentages and add them together and do it in one thing. You have to do it in two. Okay, to be the exact same, you got to do the exact same thing, even though it's really, really close. It's not exactly the same. All right, let's see. We're actually going to move here to earning interest. Okay. So the other way that bank accounts could work, instead of you taking out a loan, is you can actually put money into a bank, typically a savings account, but it could be other things. And so a bank account has a monthly interest rate of 1% and an initial balance of $1,000. Any earned interest is added to the account and no other deposits or withdrawals are made. So with this, you're putting money into an account. We're putting $1,000 into this account, and it has a monthly interest rate of $1,000. So that means that every month they're going to calculate, the bank is going to calculate 1% of your balance and give you that money into your account. You're allowing the bank to hold on to your $1,000, and so they're going to pay you, not much, 1% a month, they're going to pay you in order to make this more beneficial for you. They get to also use your money for other things while it's in the bank as you go. So, and it's also important, there's no other deposits or withdrawals being made here in this process. So we need to look at this. The balance after 6 months, 1 year, 2 years, and 5 years. Remember, we always have A times B to the X power. So our starting amount is 1,000. If our interest rate is 1%, okay, then we have to do 1 plus 0.01. That's 1% as a decimal because you would move it over twice and fill in a 0 there. So we're going to multiply it by 1.01 to the 6 months, so 6th power. This is a monthly interest rate, so you are needing to use months here. When you do that, and rounding to 2 decimal places, we get, $1,061.52. It asks for 1 year. Now we can't just put 1 in there because if we put 1, that's going to be a smaller number than this. And if you're gaining interest, it wouldn't make sense that your amount of money would go down the longer you have it in the bank if you're not depositing or withdrawing any other money. So this would need to change into months. There are 12 months in a year. That's going to give us $1,126.83. Okay. It asks us for 2 years. So how many months happen in 2 years? So it's going to be 24. And that's going to give us $1,269.73. Again, you're rounding to 2 decimal places. It's not exactly this amount of money. And the last one, it asks us for 5 years. So if there's 12 months in a year and there are 5 years, we're going to take this to the 60th power and get $1,816.70. Now, this is all dependent upon the fact that you're putting $1,000 in and you're not doing anything else with it. So sometimes you'll see that people will open up a particular savings account just to save money that they know they're not going to touch. Okay, that they're not going to put more money into or take more money out, just so that it grows more as you go. All right, so we want to write an equation then for this, expressing the account balance A in terms of the number of months M. And again, we're assuming that all interest continues to be added to the account. We're not taking anything out. We're not depositing anything or withdrawing anything. So with this, they want the account balance. Well, that's going to be A. We started with 1,000 and our growth rate was 1.01 because of the 1% monthly interest rate. And then M is the number of months. Okay, in terms of means this is your input value, so that needs to be your exponent here. All right, it says how much interest will the account earn in 1 year? What percentage of the initial balance is that? And show your reasoning. So 1 year we already calculated up here. So we would take $1,126.83 and subtract the original 1,000. And that means that we would get $126.83. So just for letting my money sit there in the bank for a year, not touching it, I've made $126.83. A pretty decent amount of money for not doing anything. Now that requires you to not touch the money at all though, which could be difficult. So what percent of this, of the original money is that? So we would take that amount and divide it by the $1,000 we started with. Okay, which gives us 0.12683. That's not our percentage though. What do we have to do to get back to the percent? Well, we're going to have to move this 2 spaces over. So this would be 12.7% if you round that. You could also say 12.68% and be okay. All right. So then the last question that we have here says the term annual return refers to the percent of interest an account holder could expect to receive in 1 year. That was the 1%. Okay. If you were the bank, would you advertise the account as having a 12% annual return? Why or why not? Would you use your work to show your explanation? So with this, if you have 1% each month at the very beginning of the question, then over the course of it, it looks as though you would get 12%. But we got 12.7% here as what our actual, and we're going to call that the effective interest rate. Okay. So the effective interest rate equals 12.7%, and the nominal, we'll call it, interest rate equals, rate, if I can spell it, equals 12%. So I would say no, because 12.7 is, we'll say, not equal to 12. So we would want to make sure that we are saying it's 12.7% so people know they're going to get more money into their account. That's it.